start with a problem you have definitely run into, even if you never named it. You go to search for something, you type in what you are looking for, and you get nothing useful back, even though you know the thing you want is in there. You search a help center for how do I cancel, and it misses the article titled Ending Your Subscription because not a single one of your words appears in it. That is the deep weakness of old-fashioned search. It matches words, not meaning. It has no idea that cancel and ending your subscription are the same thing in a human's head. Today I want to fix that, and in doing so I am going to explain embeddings, which sound intimidating and are actually one of the most useful and surprisingly simple ideas in all of this. By the end, you will not just know the word, you will understand it well enough to build a search with it. The core idea is a map of meaning. Here is the whole thing in one picture, and if you get this picture, everything else is just details. Imagine a giant map, except instead of places, it holds meanings. Every word, every sentence, every idea gets a specific spot on this map. And the rule of the map is simple. Things that mean similar things sit close together, and things that mean different things sit far apart. So cat and kitten are practically neighbors. Cat and dog are a bit further, both animals but not the same. Cat and car, despite looking almost identical as words, are on opposite sides of the map because they mean nothing alike. Notice what just happened. The spelling stopped mattering, and the meaning started mattering. That is the entire trick. Once you can place meaning on a map, finding related things becomes as easy as finding what is nearby. And the beautiful part is that we can actually build this map with real numbers automatically for any text we want. Think about how much that quietly fixes. Old search forced you to guess the exact words the author used. If you and the author thought about the same idea in different language, you were just out of luck. The map of meaning throws that whole problem away. You do not have to match anyone's words anymore. You only have to be near them in meaning. You can search for a feeling, a concept, a half-remembered idea, and land on the thing that captures it even if it does not share a single word with your question. That is a genuinely different kind of search, and it is the thing embeddings unlock. So what is an embedding really? So what is an embedding? An embedding is just the address of something on that map of meaning. On a normal paper map, an address is two numbers, how far across and how far up, and those two numbers pin down one exact spot. An embedding is the same idea, just with a lot more than two numbers. A typical embedding is a list of hundreds, sometimes over 1,000 numbers, and together that long list pins down one precise location in a space with that many directions. Now your brain cannot picture a space with 1,000 directions, and that is completely fine. Neither can mine. You do not need to. The math does not care how many directions there are, and everything that is true on a flat two-number map is still true up there. So whenever you hear someone say embedding, just translate it in your head to a list of numbers that says where this piece of text sits on the map of meaning. That is all it is, a fancy address. The jargon makes it sound like wizardry, but it is coordinates, and coordinates are something you already understand. People sometimes ask me why you need so many numbers. Why hundreds? Why not just 2 or 3? And the honest answer is that meaning is complicated. There are a huge number of ways two pieces of text can be similar or different. They can be about the same topic, or share a mood, or use the same tone, or sit at the same level of formality. A two-number map only has room for 2 of those directions before everything starts crashing into everything else. Give the map hundreds of directions, and there is finally enough room to keep all those shades of meaning separate. Each number you add is just another way the map can tell two ideas apart. That is all the big number is. More room to be precise about meaning, nothing more mysterious than that. Something text into coordinates. Okay, so where do these numbers come from? You do not assign them by hand, obviously. You use a special kind of model, an embedding model, whose entire job is to read a piece of text and hand you back its coordinates. You feed in a word or a sentence or a whole paragraph, and out comes that list of numbers, its address on the map. These models learn to do this by reading enormous amounts of text and noticing which words and ideas tend to show up in similar situations. Words that get used in the same kinds of sentences end up placed near each other, And that is how the model figured out, with no one ever telling it directly, that cancel and ending your subscription belong in the same neighborhood. The key thing for you, as the person building something, is that you do not need to understand the insides of that model at all. You treat it as a simple machine. Text goes in, coordinates come out. That is the whole interface, and it is genuinely that easy to use. And I cannot stress enough how freeing that black box is in practice. You do not have to understand neural networks. You do not have to understand training. You treat the embedding model the way you treat the electricity in your wall. You do not need to know how the power plant works to plug in a lamp. You just need to know what goes in and what comes out, and you can build genuinely useful things on top of it the same afternoon you learn it exists. That gap between how intimidating it sounds and how simple it is to actually use is most of why I wanted to make this video. Measuring how close two things are. Now we have a way to turn any text into a point on the map, and the last piece is measuring closeness. If two pieces of text are near each other on the map, they mean similar things. So given two embeddings, two lists of numbers, I need a way to ask how close are these 2 points, and there is a clean mathematical way to do exactly that. You do not need to know the formula by heart, you just need the intuition. It takes two of these addresses and gives you back a single closeness score. A high score means these two things mean nearly the same thing. A low score means they are about totally different things. That is it. So the recipe for search by meaning is now staring right at us. Take everything you might want to search through, turn it all into points on the map ahead of time. Then when someone searches, turn their question into a point too, and just find the existing points that sit closest to it. Closest on the map means closest in meaning, and that is the answer you actually wanted. Let me build the search step by step. Let me make this real, because it is genuinely just a few steps. Say I have a few hundred help articles, and I want a search that understands what people mean. Step 1. Ahead of time, I run every article through the embedding model and store its coordinates. This only happens once, and from then on each article is just sitting there as a point on the map. Step 2. When someone types a question, I run their exact question through the same model to get its coordinates. Step 3. I compare the question's point against all my stored article points and score how close each one is. Step 4. I sort by that score and show the closest articles first. And that is it. That is a meaning-based search, and the core of it is genuinely just those 4 steps. Someone types "how do I cancel?" That question lands right next to the article about ending your subscription, and the right answer comes back to the top, even though they share 0 words. The first time you see that work with your own data, it feels a little bit like magic, but you now know there is no magic in it at all. And once you have built it once, you realize the same 4 steps barely change no matter what you point them at. Swap the help articles for product descriptions, and you have a product search. Swap them for past support tickets, and you can find the closest old ticket to a new one. Swap them for paragraphs of a long document, and you can jump straight to the relevant passage. The data changes, the recipe does not. Embed everything once, embed the question. Find the nearest points, show them in order. Learn that single pattern, and you have learned the engine behind the startling amount of modern software. What this quietly powers everywhere. Once that clicks, you start seeing this exact machinery hiding behind a huge amount of what feels smart in modern software. The recommendation that says you might also like this. It is often just finding nearby points on the map of meaning. When you give a chatbot a pile of your own documents and it answers questions from them, the way it finds the right passage to read is, very often, exactly this. It embeds your question, finds the closest chunks of your documents, and reads only those. That pattern has a name, but the engine underneath it is the simple search we just built. Grouping similar support tickets, spotting near duplicate content, sorting feedback into themes, all of it leans on the same one idea. Turn things into points on the map of meaning, then look at what is near what. It is a genuinely small idea that shows up absolutely everywhere once your eyes are open to it. Let me be honest about the limits. Now the honest part, because embeddings are powerful, but they are not magic, and I am not going to pretend otherwise. First, they are only as good as the model that made them. A great embedding model places meaning beautifully. A weak one smears things together, and your search gets fuzzy. Second, the model has a point of view baked in from whatever it was trained on. and it can carry odd biases or just plain miss the meaning of very specialized jargon it never really saw. Third, this is not free at scale. Generating embeddings costs a little for each piece of text, and once you have millions of points, finding the nearest ones quickly needs real tools built for that job, not a simple loop. And finally, closeness is not the same as correctness. The nearest article is the most related one, but related is not always right. So for anything that truly matters, you still want a human or a stricter check in the loop. There is also a subtle failure people forget. The search will always hand you back the closest thing it has, even when nothing it has is actually a good answer. If you search for something your collection simply does not cover, it does not say "I have nothing." It cheerfully returns the least bad option, which can look confident and be completely useless. So you usually want a cutoff, a minimum closeness, below which you treat the result as no good match found, rather than pretending. None of that takes away from how useful this is. It just means you use it with clear eyes. So should you learn this? So is this worth your time? If you only ever do exact lookups where the words always match perfectly, then plain keyword search is fine, and you can skip all of this. But the moment you want software to find things by what they mean, the way a person naturally would, embeddings are the single most important idea to have in your head. And the wonderful thing is how little you actually need to hold. Forget the scary high-dimensional math, just remember the map. Text becomes a point, similar meanings sit close, and search becomes finding what is nearby. Hold onto that one picture, and you can reason about embeddings, retrieval, recommendations, and half the clever features in modern apps without ever getting lost in the jargon. It is one of the highest leverage ideas you can pick up in this whole space, and it really does fit in a single afternoon. That is the whole idea, from a search that misses the obvious to one that actually understands what you meant, built on nothing more than turning meaning into points on a map. I am going to keep taking the intimidating sounding pieces of AI and showing you the simple idea hiding inside each one. If that is your kind of thing, subscribe and follow along because there is a lot more coming. Thanks for watching, and I will see you in the next one.